Electrical Brains welcomes you all. In last session, we discussed about memory organization of 8051 and also about the I/O ports of 8051 we are having. In this session, we are going to discuss about a basic topic of timers, interrupts, serial port, and oscillator and a clock circuit. In this unit, we'll be going to study about only the basics of this timers, interrupts, serial port, oscillator, and clock circuit. But in future videos, we will discuss about in detail about what is a timer, what are the types of interrupts we are having, and what are the types of serial ports we are having, and about their modes we will discuss. In this session, we'll discuss about the basic concept of timer circuits, interrupts, and everything. Timers. Timer is a 216-bit register. Already in a very first feature of 8051 we discussed. This timer is having lower mode and a higher mode. TH0, TL0. These two will take 116-bit, and this TH1 and TL1, these two will take 116-bit. The T0 and T1. That is timers and counters. Mainly, what is a timer and counter is that which will count the external events taking place and producing a clock pulses. See, this is a clock select circuit. That is, if I am getting a signal from a oscillator circuit, that is from 8051, okay, from 8051 if I am getting, this is an internal clock circuit, okay. If I am getting a signal from external clock circuit, okay, this clock pulses will be enabled. So depending upon the clock source, whether it is an internal oscillator circuit or external oscillator circuit, that is the first step in timer circuit. Once the clock circuit is determined, that is either internal or external, it will produce a clock pulses. Okay, so whenever it is producing a clock pulses, if I am using a timer circuit, what is this timer is that in 8051 from 000 to FFF, it will produce count the pulses. Okay, once it reached the FFF circuit, that is FFF number, then what it will do is it will overflow it, and again it will start counting from 000 as like our stopwatch. Okay, so continuously it will just count the pulses or number of events taking place in an 8051. So once the pulses are created and if a timer overflow is set, okay, then what it will do is it will be enabled. Okay, if it is again resetted, then what it will do is it will be disabled. If no overflow has been taken place, then this timer will be disabled. Here overflow is 0. If this overflow is 1, okay, then what it will do is this timer will be enabled. Okay, what is this overflow is that the timer will count from 0 to FF. Okay, see FD, FE, FF. Once FF has been reached, what it will do is this count will reset to 0. Once it resets to 0, then there will be no overflow flag. This timer will be enabled. Okay, when this is exceeding FFF, then there will be overflow flag will be set. Okay, at the time this timer will be enabled. Okay, interrupt enable circuit. Okay, this is a basic concept of timer. Timer is nothing but it will count the pulses or count the number of events taking place in the 8051 circuit. When it is exceeding one cycle has been completed is that one time it has been counted from 0 to FF. That is one count. Okay. So once this FF has been exceeded, then that is overflow. Okay, because it's going to again start counting from 000. Okay, that is timer overflow. If it is counting in T0 mode and if this timer flow is overflowed, then TF0 flag will be set. If it is operating in T1 mode and at this T1 mode when it is operating, it is producing a overflow flag will be set as TF1. That we will discuss about in interrupt sources. We will discuss about what are the types of interrupts we are having. Okay, this were timers. The interrupts and interrupt vectors. What is this interrupt and interrupt vector is that, see, there are 4 types of interrupts we are having. What are the major types of interrupts is the timer interrupt, external interrupt, and serial interrupt. And this reset is one of the type of interrupt. See, here is the interrupt name and in which location it is accessing. Okay, reset interrupt is accessing at a location 000H. H is nothing but it indicates the hexadecimal value. Interrupt 0, this interrupt 0 and interrupt 1. These two are the external hardware interrupts. Okay, interrupt 0 and interrupt 1 are the external hardware interrupts, and this is carrying a lamp location is 3 and 13. Okay, 3 and 13. This timer 0 and timer 1, that is TF0 and TF1 is a timer overflow interrupt. Okay, this is accessing a vector addresses B and 1B. And next one is a serial port which will receive and transmit the data. It is accessing a location 0023H. Okay, this is about what is interrupt and interrupt sources. Before knowing about the classification of interrupts, we need to know about what is that interrupt. Interrupt is nothing but a small disturbances in a short form. If a main program is running in 8051 controller, okay, main program is running, sudden workers from a CPU we are getting, okay, main workers going on in a main program place, and another sudden workers given by a CPU, that is from a special function register or from any other source. I need to complete that immediately. Okay, that is at end of execution, or I need to transfer it to the user side. That is the emergency condition in controllers. So if I want to complete the task, so what this main program will do it will just hold or pause the current process taken place in a 8051 controller. It will pass that current operation and it will execute the emergency operation, okay, which is given by the CPU. Once the task has been performed, okay, from which place it have resumed, it will continue the main program from that place. That is the interrupt. Okay, let us consider a small example as if we are going for a hospital, okay, emergency condition patient like a cardiac arrest patient has been taken to the hospital, okay, and normal headache or a fever person also coming to the hospital at the same time, or a fever person is getting treatment, okay. So what the doctors will do is immediately they will give first aid to the cardiac arrest patient. They will hold off the fever patient, okay. So once the cardiac arrest patient has been treated first by giving a first aid, what that they will do is they will transfer that cardiac arrest patient to the ICU. Okay, just by giving a first aid and finishing his service, and they are transferring him to the ICU for further processing. Okay, and this fever patient is on hold, right? So they will continue the giving medicine to that fever patient and they will send off him. Okay, that is a emergency. For emergency, we are treating them first. Okay, as like that, this interrupt will perform. Okay, now I hope that you will understand what is an interrupt. Okay, that is, if it want to complete the task immediately at the time during an emergency condition, it needs to complete that first. Okay, so we'll be just holding off the main program and we are just serving that first urging person immediately, and again we will continue with the same work what we are having. Okay, that is called as an interrupt. So to accessing this interrupt, we are having some addresses. Okay, if I want to access an external interrupt, I need to go with the RAM location 3H. If I want to access a timer overflow flag of interrupt as T1, I need to go with 1B location. If I want to access a serial port, I need to go off with 2-3 location. Okay, that is of interrupt vectors. Next one is interrupt sources. What is the interrupt sources is that is the which first we need to start a program and we need to fetch the instruction and we need to execute the instruction. Okay, if I haven't treated any interrupts, then that will be disabled. Okay, if I'm going to serve an interrupt, okay, then the interrupt pin will be enabled and these interrupts will be just stored with the interrupt service routine or an interrupt subroutine. Okay, from this it will be given to instruction and we will be executing it. Okay, just saying this is a interrupt 0, external hardware interrupt 0. If it is 0, then it will be giving output in this NOT gate, okay, to the IE0. If it is 1, that is external hardware interrupt is 1, it will be accessing this to this SCR and it will be making this IE1. Okay, just remind that if it is 0, interrupt 0 is that if it is external hardware interrupt is disabled, it will producing output to this NOT gate and it is producing in IE0. If this interrupt, external hardware interrupt is accessed, then it will be 1, then it will be given to this thyristor and it will be producing output as IE1. This TF0 and TF1 is a timer overflow flag. Okay, if I'm operating in a timer 0 mode, then this overflow flag will set. If I'm operating in a timer 1, this overflow flag will set. What is this TA and RI is that transmit interrupt and receive interrupt. That is a serial port interrupt. If I'm getting an interrupt in a transmission side, then this will be 1 and this receive interrupt will be 0. If I'm getting a interrupt in a receive interrupt side, then this will be 1, this will be 0. Okay, this is a OR gate. These are the sources of interrupts, right? Next one is a serial port. What is that serial port is that in an 8051 we are having a serial data. Okay, serial data is that we need to send the data bit by bit to the from microcontroller by using RS-232. Okay, that is one of the interfacing. We are by using RS-232 we are going to transmit or receive a data to the controller or a personal computer. Okay, this is a transmitter side, this is a receiver side. Why I'm having this TX and RX is that it will serve in a full duplex mode. Okay, serial port works on the principle of full duplex mode. So I can either transmit or receive data, okay, in both the sides simultaneously. Okay, see this is the data to be transmitted. Okay, this is the transmitter side, this is the receiver side. See here I'm going to give an instruction. Okay, if I'm loading a 000, this is given to a controller. From controller, once this is 00, this clock will be enabled. For 00 also it will be enabled, for 1 also it will enable. If it is 00, now it is enabled. That is, it is going to give an input to the transmitter side. What input I am giving to the transmitter side, that must be the output I get in a receiver side. Okay, now I have fetched the input as 000. So this clock pulses is enabled. When it will be enabled is that once it is load the data to the transmitter side. See, the 00 is load to the transmitter side. Once it have been loaded, then this serial clock will be enabled and it will send a signal to the receiver side, that is 0000. Okay, so this 0 is transmitted in a transmitter side and from transmitter side it is received in a receiver side. Okay, what data I am giving in a transmitter, that must be received in a receiver side. It should not be mismatch. Okay, so from by bit we can receive a data and transmit a data in a serial communication. For each time I have uploaded a data, this clock pulses will be enabled. Pin 10 and 11 are the RXD and TXD pin. That is, this is for transmit line and this for receiver line. That is, it will be linked, interconnected. Okay, this is a data bus. Okay, this SBUF is a register. Serial buffer is one of the read-only register. Okay, in this side, that is in the receiver side, we can read only. In a transmitter side only, we can write the datas. Okay, that is transmitter side is nothing but it's like an input side. So that in this session we can write the data, but in a receiver side we can only read the datas. This is a serial port. Next one is a oscillator and a clock circuit and T state. What is the oscillator circuit? That is we are having ceramic crystal oscillator we are using. We can use from microfarads, that is 20 microfarads. We can use 20 to 30 microfarads. Anything we can use. Okay. Why we are using particularly this oscillator is that to maintain a stable clock frequencies. Okay. See, here is a one machine cycle. This is about oscillator. Why we are producing oscillator using oscillator? We are using oscillator to produce a stable clock pulses. See, this is a clock pulse. Each clock pulses is producing one T state. Okay, this is state 1. That is, each state will be having two pulses. That is P1 and P2 is one state 1. State 2, state 3, state 4, state 5, state 6. So, one pulse, if I'm using a 12 megahertz crystal oscillator, 1 megahertz crystal oscillator, I'll get 1 microseconds. In time period, if it is 1 microseconds, I will get. Okay, that is T equal to 1 by F. Okay, so from that we will be getting a value. Okay, so 1 microseconds I'll get. 1 microsecond is that for one machine cycle, okay, we'll get 12 microseconds of pulses. That is 12 microsecond clock pulses we will get. Okay, this is the one machine cycle. Here we are having 6 states. What is the T state is that? T state is that each state will be having two pulses. That is P1 and P2. Phase 1 and phase 2 are pulse 1 and pulse 2. So T state is that each state is having two pulses. That is called as a T state. What is that machine cycle? One machine cycle is that 6 T states. Okay, one machine cycle is equal to 6 T states. Each T state is having two pulses. Okay. Machine cycle depends upon the architecture of a controller or a processor. So for each type of architecture, this machine cycles will differ. Okay, and then what is an instruction cycle is that it will be producing a cycles based on the instructions. Okay, in 8051 controllers, we are having lot of instructions. So based upon the instructions, it will be producing cycles. Okay, this is about oscillator, clock, and T state, and machine cycles and instruction cycles. Okay, so far we have discussed about what is a timer, interrupt, oscillator and clock circuit, and serial ports. In next video, we'll discuss about the instruction cycle of 8051 and how the instruction cycle is carrying a bytes and a cycles for each instruction, and how we are drawing the timing diagram. We'll discuss in the next session, as well as the power and reset circuit and overview of 8051 families we'll discuss there. Okay, thank you.